Now it's important to keep in mind that the graphs we've been drawing in the plane are still lines in the geometric sense. So it makes sense to talk about the line parallel to a given line. Let's take a moment and recall what it means for lines to be parallel. Two lines are said to be parallel if they never intersect. Now, let's keep in mind carefully what that means. Remember that lines extend forever. So being parallel doesn't just mean that we never see them cross. These two lines, for example, we don't see them cross, but if we were to extend in a straight line beyond, we see them getting closer and closer together. And if we move them over a little further into the page so we can continue to extend them, we see that they do eventually meet way over here. And so these lines are not parallel. How can we get parallel lines then? We can find a line parallel to any particular line we're thinking of by translating the line, that is, moving the line without turning it. So for example, if I give you this line, we can get a line that's parallel to it by just copying the line and moving the copy around. And we get these two lines are parallel. Okay, that's neat and all, but how would we write down the equation of this line? Well, before we could do that, of course, we'd need to know where our axes were. So let me draw in an x and y axis. It looks like our given line runs pretty neatly through these 2 points. So that means that its slope over 3 down 2 is negative 2/3. But when I dragged those points, as we can see, the whole triangle just went along with the line. So the slope of this parallel line must be the same. And in fact, that's always going to happen, right? The whole triangle is always going to go along with the line. So to write the equation of our new line, we just need to find a nice point. And it looks like this point is very nice indeed. Right, so this line has slope negative 2/3, and in fact that point we're looking at is the y-intercept. So y-intercept 4. And so our equation is y equals the slope times x plus the y-intercept. Once we know the slope and a point on the line, we can always give the equation. Okay though, how could we do that without the picture? Say we wanted to find the line parallel to y equals 2x plus 3 that goes through the point 5, negative 1. Well, there are 2 steps to this process. First, we find the slope of the given line, and we can just see that in our given equation. So in this example, the slope is 2. Then, once we know the slope, we'll write the equation in point-slope or slope-intercept form. In this case, we are not given the y-intercept, so we'll use point-slope form. Y minus the given y equals the slope times x minus the given x. Simplifying that just a little bit, instead of minus -1, we'll write y plus 1 equals the slope times x minus 5. And there we go. This is the equation of the line parallel to the given line through the given point. It's a very simple process. We just need to remember what it is we're trying to accomplish.